The Doppler effect is the apparent change in the frequency of a wave caused by the relative motion between the source of the wave and the observer. We can find what the frequency we are hearing by knowing what frequency is being emitted and adding or subtracting depending on whether or not the wave is moving toward us or away from us. We can find this by using the Doppler effect formula. This is used for finding the perceived frequency. As you can see, right here, we have small wavelengths but high frequency. And over here, we have long wavelengths but low frequency. In this problem, a police car is moving toward children at 40 kilometers an hour. The police car is creating a frequency of 3200 hertz. However, the children are going to hear a different frequency because the car is moving toward them. To find the frequency, we're going to use our formula, where this is f prime, so this is what frequency they're going to be hearing. And this is the frequency that we start with. So for example, it's going to be like this. One. Now, to tell if you add or subtract, that is dependent on whether the vehicle is moving toward the observer or away from the observer. If you're moving toward the observer, you're going to add. If you're moving away, then you subtract. So because the car is moving toward the children, we're going to add. So we're going to add the velocity of the car. Now this is in kilometers per hour. We're going to change that to meters per second. So it's going to be 11.1 meters per second. So we're going to go 11.1 divided by 340 because that's the speed of sound. So when we do this, we get 3200 multiplied by 1 plus 11.1 divided by 340. This is going to equal 3,304 hertz. So this is the frequency that the children are going to be hearing. The speed of sound can be altered depending on the temperature of the air. When molecules are closer together, sound is transmitted much faster. So, the formula we use to find out how quick the speed of sound is using this. So Vs is going to equal 0.6 multiplied by the temperature plus 331.5. So in this question, it is 36 degrees outside. Someone is speaking at 1250 hertz, and someone is moving toward him at 4.6 meters per second. What frequency will he hear, or she? So, we know that it's 36 degrees outside, so we're going to plug this into our formula. We're going to go 0.6 multiplied by 36 plus 331.5. So this is going to equal the frequency that this person is going to be hearing. So this is the frequency that this person is hearing, even though that they are speaking at 1250. Thank you for listening, and I hope you have a better understanding as to how the Doppler effect works and how to use the formulas with them.